Algebra 2, we're on practice final number 1 in this video, but only needing to do the first half up to 28. We had 1 day to spare where we could do one of these reviews in 2 days instead of 1, so I went with the first one because it's the oldest stuff and it might have faded the most. I think the more recent stuff is going to come back a little quicker, but this original one a little rougher maybe. So we're working today in this video up to 28, and then the next video will go from 29 to the end. So for number 1, we're just looking to put the numbers in for the variables. So 7's going to go in for x and make 7 times 7 is 49. 11's going in for y, so 6 times 11 is a 66. Add those together. And then subtract 5 times 9, which is 45. Do the math on that. And I'm not going to keep saying the answers because you should have an email version of the answer key by this point in the day. Just see if your answers agree with mine. 2, the absolute value bars are like parentheses. You do what's inside them first. So inside the bars on 2, you should get negative 9, and then the bars would zap that into becoming 9. 3, negative plus negative makes a negative, and you add them, that's negative 30. Don't use a calculator on that problem. Calculators would be banished from 3 to 6 at least. 24, we're doing a negative minus a positive, make a bigger negative, that's negative 26. 5, a little canceling, 3 and 6 can cancel to leave a 2 on top, multiply across, it'd be 4 11ths, but negative because when you multiply one of each, it's negative. 6, when you divide 2 negatives, makes it positive. 7, when we're multiplying, we want to add those powers. Copy the x and add the powers together. For number 8, we want to subtract the powers. The coefficients we're still going to divide as usual, so 18 dividing 6 makes 3. When you subtract the powers on the x's, 4 minus negative 3 has a little minus minus making plus. 4 plus 3 to get the x up to 7. And then the y, if you do negative 1 minus 6, that would be a negative 7. And you could either write everything side by side without a fraction, as I wrote one of the answers, or you could make things back into a fraction if you prefer. That's up to you. 19, when powers go to powers, you multiply the powers. 10, scientific notation, the rule is you have to plop the decimal down to make a number between 1 and 10. So if you put the decimal right after the 2 to make 2.34, that's a number between 1 and 10. And then it's always times 10 to a power. The power is a count of how far the decimal just moved. On number 10, the original decimal was all the way at the right. If you move it all the way to be here, you would have moved it 8 positions. 11, you're just working in reverse. The negative power means to move the decimal to the left 3 positions. So you take the decimal from after the 5, move it 3 positions, and you get a decimal at the beginning, a couple zeros, and then the same number. 12 is like 8. Divide the numbers to get 4, subtract the powers to get 3, and just write it as scientific notation. 13, we multiply the numbers. 5 times 6 is 30. Add the powers on 13 like we did on 7, and it would go up to negative 3. This would be pretty good if this had the directions of number 7. But the directions here are talking about scientific notation, and this isn't anymore, because scientific notation can't have a number over 10. So this has to go down to 3, which makes this in payment go up. If one goes down, the other goes up. So if you go up from -3, you'd be up to -2. If you don't believe me, look at the number line from -3, go up. For 14's group, just doing opposites. The problem subtracting 7, so you add 7. 15, you have 2 opposites to do. Add or subtract first, even though the order of operations likes that to happen last. The order of operations also goes somewhat opposite when you're doing your opposites. So add 8 to 46 to get 54, and then divide by the 9, that'll get you a 6. 16, you can either be great with fractions and do opposites, subtracting a 3/4 to change this, and then dividing by a half, which flips it to change things. More frequently during our year though, we multiplied to clear the fraction. With these bottoms, 4 would be the common denominator or the LCM. So multiplying by 4 would cancel this 4, would cancel this 4. 4 would cancel 2 to make a 2 that multiplies the top to get this equation instead of that, and then your opposites are maybe easier to do. Subtracting 3 to get 2, dividing 2 to get 1. 17, we need to remember from Algebra 1 and 2, when it talks about consecutive evens or odds, the standard names are x to start, x plus 2, x plus 4, if it had more numbers, x plus 6, x plus 8, if it were evens and odds. If it didn't say even or odd, but just consecutives, this would be 1, and then 2, and then 3, 4, 5, and so on. So we need to know those names. The story says we want to do 2 times that first one, plus 3 times that second one, plus 4 times that third one, and it is 103. You'd want to distribute all of that. You'd want to combine all those like terms. If you do that right, you'd have 9x plus 22 equaling 103. And then do opposites. Subtract 22 to get down to 81. Divide by 9. So our list would start with 9. But remember, we wanted a list of 3 numbers, and they were supposed to be odds. So 9 would bump to 11, and then to 13 if we're sticking with odds. 18, we're doing opposites just with lots of letters. If our goal is to get the L alone, we have to get rid of the W. So we would divide by W to eliminate the W's. This side we could divide by W, and that's all we can really do is have an A on top of a W. For 19, we're after B. So I don't want to distribute to half, because if I did, I'll have fractions everywhere. So I want to eliminate this by doing the opposite. It's trying to multiply, so I'll divide. Dividing makes it flip. A half flipped. 2 over 1 is better known as 2. So I have a 2 next to the A once I got rid of the half. The H wants to divide. So if I divide by H, that puts H on the bottom. And then the A is trying to add, so I'll just subtract the A, and that won't be part of the fraction, that's just there. 20, we're not graphing on graph paper, we're just graphing on the number line. So I'm talking about 3, so we do a thing like that, and then the choice is whether to fill in or not. We fill in if we see an equal sign, and on number 20 I do see an equal sign, so I'm going to fill in, and then I go left or right. Since this is a less than question, I go left. 21, we're going to solve just like we would an equation doing opposites. The only small modification on these is if you divide or multiply with negatives, the signs turn. That's not an issue on 21 because we're just subtracting 6's. But when you write the answer, you need the x there and the sign still to be there because it may or may not turn, and I need to see that sign and not just write the 1. 22, with variables on each side, I would choose 1 to eliminate. I feel like subtracting 2x is the better bet because that keeps me positive and avoids that rule I just talked about. If I subtract 2x, I get 2x minus 13 greater than negative 5, and then do opposites. Adding 13 would turn this into 8, and then dividing by 2 would get the x alone, and the 8 would be a 4. If you had this written as x and then 4, that's an okay answer too, but the alligator is hungry and needs to eat the 4, whichever way you have your answer faced. 23 is talking about tests. So we have this test, this test, this test, this test. We're adding up all the tests, but we need to add in a 5th test that's a mystery. And the comparison number here to get our A is 450. It's not just equaling 450 though. We could be greater than 450 and we'd still be good. So I want to do that symbol with the 450. Combine those numbers to be a 361. And then do an opposite. The opposite of add 361 is to subtract 361, and we're looking at this. But the answer to word problems should always be word answers. We'd want to say here like 89 or more, at least 89, no less than 89, one of those kind of phrases in the answer. 24 we're graphing again, but not graph paper, but just a graph like this number line graph was a second ago with the 3. So put negative 5 on the left because the number line says so. Put 2 on the right because the number line says so. The 2 has an equal sign, so I'll fill that in. And then if the x is between them, we're going to play connect the dots. We also at one time did some OR graphs. The OR graphs usually went in 2 different directions. 25, we're doing opposites to solve for x. But instead of 2 sides, there's 3. So x is here. Always look for the adding, subtracting opposite first. We're going to subtract 8 to kill the 8, but not just there, also with 28, and also with that beginning negative 2, to get a negative 10, 5x, and a 20. Then we're going to have to divide by 5s in all 3 locations, and that'll produce the answer that I have. Again, none of those signs are turning because we never encountered a negative with the variable. But if you ever see a negative with the variable, all the graders and lesses would turn as you saw. 26, you basically have to memorize 3 different setups for 3 different types of problems that are determined by which sign you have. If you have an equal sign, copy the thing that's in bars, which on 26 I took it easy on you, it's just an x. So keep the x but twice. Keep the equals twice, once have a 3, once have a negative 3, and since I kept it nice and all there was an x, you're done, that's the answer. If there was something bigger in the bars, like 3x plus 6, you'd have copied the 3x plus 6 twice, and you'd have had some opposites to do with both of those. 27 is a different kind of problem because it's a greater than. The greater than questions always have the word or in them. Like the equal to ones, we copy the x plus 2 twice exactly as it was. But for one of the problems, have it be greater than the normal 8 that I gave you. In the other problem, it's less than a negative 8 that you have to change a sign from what I gave you. And then do opposites. Subtract 2 to solve to make that 6. Don't forget to write the word or. And over here, subtract 2, we go down to negative 10. 28 with a less than, we used to call these less than sandwiches. The item that's in bars that I give you, 3x plus 3, you copy it down completely unchanged. When you do your copy nows to make these problems get created, you don't change any of the signs of anything in the bars. Just copy 3x plus 3. Surround it with 2 less thans, hence the nickname less than sandwich. Put normal positive 15 on the high end, put negative 15 on the low end, and then do opposites. Subtract 3 on both ends. So we'd be to a 12, we'd be to a negative 18, and the 3x just sits. Then on all 3 locations, we would divide by 3s and you'd get the answer that's on your key. If you need more help than that, email me, we'll talk on Zoom, we'll work it out somehow. Next review will kick in from 29 to the end.